Now I'm delighted to introduce Dr. Tracey Lauriault from Carleton University. Dr. Tracey Lauriault is Associate Professor, Critical Media and Big Data at the School of Journalism and Communications, also with Digital Humanities and the Institute for Data Science at Carleton University in Ottawa, Canada. She's one of the founders of Critical Data Studies. Ongoing research involves data preservation, digital twins, smart cities, data brokers, and Indigenous data governance. As a publicly engaged scholar, she mobilizes her research into data and technology policy, and as a technological citizen, she aims to make data and technological systems more just, inclusive, equitable, and sustainable. Welcome, Tracey.
Thank you. I can just operate from here?
Yes, you can.
Lovely. I'm between you and lunch. So I'm going to take a really long time here because we're all really hungry and we're really warm. Thank you, everybody, for being here. I'm really excited to talk about where we're at with digital twins. But first, I just want to let you know that we're actually bringing together two state-funded projects. One is the Archives 4.0 project, which I don't need to introduce any further because you've heard lots about it. However, it has 4 objectives, and one of the areas that I will be working towards with this particular case study is to test some of the research being done in the project through a particular case study called the Digital Twin Case Study. In addition to that, I'm bringing together a new frontier in research grant project called the Digital Twin, or Imagining Canada's Digital Twin, and that is the funding of high-risk, high-outcome kind of research in the context of Canada, and they're very, very difficult grants to get. So it's very nice to be able to bring these two together, and that is situated in the School of Architecture and Engineering. The research questions that guide the work that I'm doing, and Annalena Tejas was listed there. She's a graduate student that's working with me at Carleton University in media studies. And the research question that we have is this one. Well, if digital twins intermediate and automate actions and decisions that affect social and material outcomes for all of us, how ought records about those actions and those decisions in these very complex automated systems be managed and archived or preserved? That's one. The next one is can artificial intelligence and machine learning actually help with the preservation of a digital twin? And the jury is still out on my part. I'm not sure, and you'll see why I'm not sure, because I'm still not sure what a digital twin is based on the research that I've done with Anna as well. And how would one archive the artificial intelligence and machine learning processes that are part of these really complex systems? Can they also be preserved in a system? So these are the big research questions that are driving the way that we're doing things. These are our research goals. We're going to study the Carleton Immersive Media Studio Digital Twin, which we have done. We're going to test the preservation of it. So that's a next step. Probably next year, we're going to see what it is we can bring into the institutional archive at Carleton University. We're going to assess if we can use any kind of artificial intelligence to automate the process of bringing this in. And what's the thing that gets brought into the archive? We don't know what that thing is yet, or what those several interconnected things might be. And then also, what of the objects that are part of the digital twin, and then of course use those results to inform those who are creating these very complex systems of systems right now to hopefully bring in the idea of archival thinking and disposition into the creation of what it is that they create, because currently they do not. It's also, to some extent, about data governance. You know, I'm in a critical data studies fields, and I really care about data governance from my world in communication and media studies and in GIS and geomatics and in governance in general. And arguably, this is what you also care about. And I liked that archivists were framed as stewards earlier on, and in a data governance framework, that would generally be the way that I would think about it as well. But how would you govern these complex systems of systems that are influencing and changing social material outcomes in real time, in real space, and potentially affecting people's lives in the long term? How ought those things be governed? And right now, there is very little governance conversations happening in the digital twin space. Now, most often, the literature is industry and government grade literature that describes digital twins in really technologically solutionist terms. Digital twins are going to save the world. You know, like really the literature is that way. Or technologically very optimistically, we could do so much more if we just had digital twins. The academic literature is scarce, particularly critical literature, and the academic literature in this space is mostly from IT and data analytics, mostly derived from systematic or bibliographic literature reviews. So it tends to be uncritical, descriptive, and very derivative, and not grounded in the actual practice of digital twins. And I think this study here was really helpful at demonstrating how far away most of those studies are in how they think about them. These two reports, however, I would say are the exception. We don't see too many. They're still quite laudatory and excited about the digital twins, but at least they were conducted in a scientific way, and they've done a really good environmental scans. And Monsieur Thibodeau was the person who introduced me to the one at the National Academies. So what are these digital twin things, right? So the definition, according to the National Academies, is to set of virtual information constructs, whatever they may be, or I would say representations in the context of a digital twin, that mimic the structure, context, and behavior of natural, engineered, or social systems, or systems of systems, if you will, that is dynamically updated with data from its physical twin. And I'll show you, I'll unpack that a little bit in a couple of seconds. There are predictive capabilities, but they're not always predictive capabilities in a digital twin, and they inform decision-making, and they have real meaning value for those who create them. What's really important, though, is this bidirectional interaction between the physical and the digital. And this is something that I'll come back to shortly. So to look at it another way, that same diagram, if you will, but looked at in another way, you've got something in the real world, a building, a cluster of buildings, a city, a region, a manufacturing plant, a car, whatever the thing may be. And you have something, a replica of that in the digital world, and you have systems, sensors, captors, data, objects, and so on that represent those things, and they speak to each other and have some kind of bidirectional feedback to influence each other. The one that I am looking at specifically is from the Carleton Immersive Media Studio. It's situated very much in architecture, engineering, construction, and owner-operated sectors. So I'm not looking at a factory floor. I'm really looking at digital twins from the lens of these actors who invest in them to manage assets, usually physical assets, a bridge, infrastructures, buildings, could be cities from an urban planning point of view. And most often it's really about quantifying and managing operational physical assets like buildings, building environments, and other physical features in the environment. So it's very specific to that sector. It's not all the digital twins. Medical imaging has digital twins. Aerospace engineering has digital twins. Car manufacturing, you know, our friend Elon, he digital twins his cars when he's designing them. So, you know, et cetera, and also the manufacturing process. Imagining Canada's digital twin is interesting in the sense that it includes people. Because almost all of the discussions on digital twins, you never hear people, and you never see or hear organizations, you never hear institutions, you never hear about budgets, and you don't hear about governance, and you hear very little about data sharing, let alone preservation and records. Again, it's this technologically enthusiast environment that just assumes that all of that happens by itself, which all of us know that this is absolutely not the case. So it's bringing in multiple actors, but it's also thinking about culture, it's also thinking about ethics, it's also thinking about inclusivity. It's envisioned, so see that same kind of bidirectional imagery that you see here that's flowing through all the different types of models that I'm showing you. The one that they want to construct at Carleton is more analogous to a spatial data twin, and it has it's quite large in scale, which you'll see, and it's federated, as in other folks will keep their data in their organizations, and the data will come together in an interoperable way so that people can add data from their different organizations into the digital twin that they're constructing, making it a spatial digital twin, not making it an autonomous, unique organizational digital twin, even though I'm looking at the one at Carleton University, right? So this is, that's the architecture building. That's the architecture building at the bottom in the context of a campus, and then the campus in the context of the province of Ontario, and then going further and bringing multiple artifacts of a similar nature together in a federated way at a national scale. I don't normally bring in product-specific, vendor-specific things, but I thought this diagram was useful to show the nature of the complexity of all of the artifacts that come in. I wouldn't necessarily characterize the social as the cloud, for instance, but just to give you an idea that depicts all the kinds of artifacts that may come into it. We're approaching this with 4 interrelated theoretical concepts. So critical data studies, which is the world that I am in, and in that world, we accept that data technological systems are never independent from the institutions, systems, tools, techniques, and systems within which they were created and used. So creation and use is a logical place for me to be in the context of this project. And I think context is what we're saying here in this particular thing. You can't take data out of their context. You need to study them in their context. Digital diplomatics, which is the study of the creation, form, and transmission of records and their relationships to the facts represented in them. So this is also important to us. Social and technological assemblage theory from our French friends, Deleuze et compagnie, in France, really looks at, takes a social constructionist view and understands these systems as being kind of ontologically complex, interconnected, loosely connected systems of content and context attributes that define them. So it's never one thing, it's multiple things together that construct the thing to be the thing that it is. And I think you were getting us to that place earlier today from a different direction. And then a combination of technological walkthroughs and digital records, and technological walkthroughs are a methodological approach used in media studies mostly to study apps. And what I'm doing is looking at this particular approach to better understand systems, and we do that ethnographically by actually visiting people, talking to people, and engaging with them. And when I say assemblage, it's really, this is an open data assemblage. These are the systems of thought and legalities and finance and political economy and records and the like, as well as the technological systems are my checkbox. So when I go visit the people that I'm interviewing, these are the things that I am looking for when I'm talking to them, in addition to the surveys and the instruments that were a part of InterPARES 2, as well as the surveys and the instruments and the conversations we've all had together. So what did we see from our first round of interviews? Now, our first round of interviews were only with the Carleton Immersive Media Studio, and they are architects in the School of Engineering, but they are mostly architects. And what we saw was all kinds of systems, and we also assumed that a digital twin had one juridical actor, and you'll see why our things changed radically as we started interviewing other people. So this diagram depicts the architectural technological perspective of SIMS. We identified multiple platforms, hardware, software, management systems, asset management systems, databases, and the like, which you can see here. Some open source, some not, some very proprietary, and some pushing the boundaries. We also discovered really interesting practices, such as building information management, architectural design, photogrammetry, image capture, all these other practices that you tend to find in geomatics that have now shifted and found their way in an architectural environment. What we also discovered is they're interested in the visual as well as managing the assets from a database and describing them, but they have nothing, they have no bidirectional systems whatsoever in their digital twin. So are they really constructing a digital twin if there's no bidirectional information? Because really what they care about is, can I replicate something in the material world, in a digital world, and can I interact with it somehow, and can I bring it into a larger spatial data system? So SIMS is after we interviewed all these folks, we discovered, well, Sims is the primary investigator of Imagining Canada's Digital Twin, and they're in architecture and urbanism, and they're funded by SSHRC. Then we met facilities and management plant because they're at Carleton University where this digital twin is being created, and they're responsible for the operations management and all the physical assets at Carleton, including the construction of those assets. So assets means buildings, means heating plants, means physical things. And they never use BIMs, although now they are starting to subcontract and developing a way to actually do that, partially as a result of us talking to them. Then we met Delta Controls. We met these folks here at the Building Performance Research Center, and they are researchers who are primarily electronic engineers who are interested in the sensors that are sensing the things in the buildings and trying to understand and code the parameters by which something in a building might change as a result of being triggered by what is sensed. And they have white box, gray box, and black box type of AI, depending on the physical systems and the artificial coding systems that they've created. And their researchers tend to graduate, get PhDs, and work for Delta, and Delta Controls are the building automation system that is contracted by facilities and plant management. So suddenly, we started off with one juridical actor, and we're finding ourselves meeting many juridical actors. Then we have corporate archives, and they're in charge of dealing with procurement records and records related to contracts with architects and engineers in terms of building information models and so on, and the management of those assets. But they don't necessarily care about looking at them, but they would have a direct connection with facilities and plant management in terms of managing their operational records in the organization. We met the building permit approval process because these are the folks, when you submit a building approval in a city, they're the folks that approve whatever buildings, and they use that data to inform their digital twin. So Carleton University would be here in their system. Then we met the geospatial data and analytics team at the city of Ottawa, and they're building a digital twin, but their digital twin, like the architectural digital twin, is just visual, three-dimensional, but just visual, and it's a GIS system or more spatial data infrastructure system. And the Carleton University digital assets can be found in this particular digital twin. And this might be some of the things that they look at, underground subsurface and other iconic things like Parliament and so on. And then we met the City of Ottawa Archives folks because they have to preserve the records of all the building permits that come in, but not necessarily the digital twin that the City of Ottawa creates, because that is not the record according to the geomatics folks. So it's an interesting assemblage, if you will, of multiple juridical actors that all have different functions and different ways of doing things, and nothing is related to one artifact called a digital twin. So yet we still don't have that one artifact. When we go back and take a look at the architectural view, we see what they do is visual. They're interested in the transformation of material things into visual things, and then describing those visual things so that you can do some VR, that you can plan, that you can integrate them, that you can manage them, that you can see them, that you can navigate in them, and so on. That is really what their interest is. They're not really interested in the bidirectional digital twin. When we looked at the second round of interviews and we met all of these other actors, well, we met engineers and managers at Facilities Plant Management. We met researchers at the Building Performance Research Center. We toured the facilities. We visited the plants. We went into labs and control rooms. We dug through stuff. We discovered that for these actors, they're informed strictly by operational data. They never look at the visual data. The visual data is not interesting to them whatsoever. It doesn't help them in their day-to-day work. Although, as you can see in the one at the top right here, that there is some visual of the circulatory system of a building. So if something goes wrong, they can go and take a look at that, see what is going on with that thing, and then they physically go to that area in a building and repair. So that's the closest to twinning from a digital three-dimensional artifact to something that is coming from a sensor. So really, it's the circulatory system of the building. Now, coincidentally, when we were at the archives in the City of Ottawa, they're using Regelvar and Delta systems as well. And when we went into the vault with the archivist, everything turned on within seconds because it detected the humidity and it detected our breathing and it detected, the sensor said there's 3 people in here, and immediately the system went on. In seconds, the whole system turned on because that is part of making sure that that's it's a climate controlled environment, and it knew that we were there right away. Now, so what did we see? So we saw that Delta Controls develops the automation systems, that Delta Control installers subcontracts out to Regelvar. Regelvar has the contract with Carleton, and so on, right? I'm not going to belabor all the details of all of these relationships, but what we discovered was multiple juridical actors, each operating autonomously, loosely connected on this banner called Carleton University, but their systems are by no means interconnected with each other at all. And this is the space where you get the real-time data, you get the AI, and you get the automation of the systems. It's really in the building operations. And at the end of the day, what's really important is monthly reports that comes to facilities and plant management from IntelliWeb that tells them that their systems are working fine. So is that the only record from a digital twin, is the building operations report that comes in from a third-party vendor that's doing the monitoring through their systems and a platform, and who's actually doing the automation, the artificial intelligence, and the machine learning. What did we see? Well, this is what we saw. We saw 3 autonomous systems of systems that fall under this banner called a digital twin, but they're actually not connected. We have the architectural view, we have the archival view from archives, the City of Ottawa archives and our administrative archivist, and then we have the operations view. They're very different, and as I said before, they're not interconnected. And we figured this out after 25 hours of interviews, and we were a little bit sad that we actually didn't discover a digital twin. We also, this is, again, from the preliminary rounds of interviews, the stuff that we're tracking. So remember that big assemblage diagram that I showed you earlier? Well, it kind of looks like this checklist where we're trying to see who cares about what where from a juridical actor's perspective. And as you would not be surprising to you, that not all the records are important to everyone all the time, but some records are very, very important to some, and they are not the exciting records that we are interested in, which is the artificial intelligence and machine learning. It's just as, does the thing work, and do I owe you any money, and what's the contract? Those are kind of the things that they consider to be important. Yet, this complex artifacts, and these complex artifacts, whether they're connected to each other as systems and subsystems or not, do monitor change the environment. And when we start getting into more high-risk environments, such as the heating plant, you start seeing engineers 24/7 in a control room, which I'm sure they have here at Regis as well. And their job is to sit there and sign a book. And their record is the engineer's signed book that says, yes, my day was fine, the system's operating well, nothing's going to blow up, and all systems and inspections are go, and we're all trained as we should be. And this is literally logged in a book at Carleton University. It's not even in a digital system. So this was, again, very, very surprising and interesting when we met these different actors. So from a knowledge preservation point of view, what is the digital twin? What is the record in the digital twin? You probably already know. You're going to scoop me in the next few months because I think you've already figured it out. Having said that, these will become interconnected systems of systems. These will become interoperable. It is nascent in their development. They are still fledgling systems, but the aspiration is that we will have these large, complex systems that will be interconnected, and that are at the moment very poorly governed, particularly when you leave one institution like Carleton University that has authority over its systems. But what about a city that has authority over multiple systems? What of the surveillance of these things? What happens when you start sharing data within these environments? What happens if when we start changing the city movements and things that happen in real time that may or negatively or positively affect people? And in the context of what we were talking about, emergency preparedness, some of the work that Eric is thinking about, like what happens when these systems fail, or what happens when you use these systems in those arenas, and how do we pay attention to them? So that's kind of where I'm going to go next with the research. What I wanted to show here is that we don't have a lot of predictive capabilities in the Carleton system. There is some limited artificial intelligence, and we're going to go figure out how to work with that, mostly in the building operations side of things. And then again, what's clear here, and I think what's really important, I think one of the things that's been very useful about this study for here and for others, is it's not a study at a distance, it's a deep research to really understand how these systems work. And it's been very exciting to go speak to people who do GIS and architecture and so on in this particular space to say, hey, folks, you don't really have a digital twin. And they say, yeah, we know. We don't really have a digital twin, but we still believe in the rhetoric, and we still use the rhetoric to say that we are moving in that particular direction. But you are absolutely, they were surprised that someone outside of their field kind of got their Potemko village, if you will, and discovered that at this time such a thing doesn't really exist, and it is not one artifact, is multiple artifacts and loosely interconnected systems of subsystems. And so that's where we're at. We will be analyzing our results. I'll be working with some of you from an archival point of view to make sure that as we go through our interviews, we capture all this essential information. And we'll identify those records for you in the next year or so. And we'll publish and share the results. And thank you very much.
Thank you, Tracey.
No questions.
Are there questions for Tracey?
Yes.
So in the reports that you mentioned, so no evidence of records being collected based on data, for example, for research data management coming from sensors, or decisions based on data from sensors, nothing?
So what those data do is they'll go to Delta, which is the subcontractor. So the sensors that are, keeping us cold and warm in this room right now, those devices in the back there, as well as fire prevention, whatever, all of those systems feed back to a subcontractor. They don't feed back to Carleton, because Carleton subcontracts that activity out to somebody else according to their specifications, engineered specifications. They get those data, and then what they do is, their only mandate is to say everything's working fine. And if something's not working fine, is to tell you that something's not working fine. And then you go and you trigger an activity to go fix the thing that is not fine. So the record, as far as I could see at the moment, is for Carleton University, is the report that says everything's fine. Because all of the other data are irrelevant to them until which things aren't fine. What I don't know is, and when I highly suspect is that Delta, Regelvar, and company are not preserving these in perpetuity, because once they've submitted their report to say everything's fine, they're done. They've fulfilled their function according to their contractual obligations with Carleton University, which was very different than, when we first met and we were talking about these idealized ideas of a digital twin. They're really not that sexy at this time, like they're not as exciting as I thought they were. It's exciting for me to discover all these things, but it doesn't do all the things. I didn't see what you're asking.
So
yes.
The blueprints will still exist.
So the blueprints exist, and the building information models, of course, exist. And the City of Ottawa archives would have the blueprints of the assets that the city manages and has authority over, as Carleton would, and they may use those and annotate those. They also have digital versions of building information models, because they procure those now from architectural firms. They no longer enter into contracts with firms that don't do this. So they've changed their practices and how they do this. The problem is the systems within which these are created. AutoCAD is a highly proprietary system, and they're afraid to open their old building information model drawings, because as soon as they do in the new version of AutoCAD, because you don't have access to the old AutoCAD, you've completely changed the original building information model that you had, because the new system reads it differently and gives you a new output. So they just leave them closed right now. They're afraid to open them.
Well, there are also issues of access by people who have bad intentions.
Not for the building information models, because they're locked up. They're well taken care of.
That's why they're locked.
No, not necessarily. No, because the images that I showed you from the architecture are those models. So they're using the models, they've created some, and they're using the ones that Carleton gave them to create those three-dimensional models that I showed you earlier. And the city does so as well. So they're embedded into these augmented realities and VR systems, or just 3D modeling that does all kinds of other things.
Yeah, but for example, in the geographic information system in Vancouver, in
Yes.
the RAM map, they don't show the sewers because
Yes,
people with bad intention could use them.
correct. But fortunately for all of us in Canada, there's almost no, we almost don't know what's going on underground, period, at the moment.
Okay.
Okay, so just, not that, that's why every time you dig, it's, every time you dig, you kind of pray that you're not breaking things. So there's a whole movement to create an underground digital twin of subsurface, for example. So yes, of course, there's things from a security and a cybersecurity perspective that you don't do, and certainly the interior things. But it's mostly these original drawings are not kept aside only because of cybersecurity concerns. They're kept aside because it is their records. They have to maintain those records, but also they're afraid to open them.
Yeah.
Because they're afraid to change them.
Would you call the case examined by the Paradata group, the Vancouver Airport, a digital twin?
They didn't go look at it. They just know that there's a digital twin. They didn't explore it. So I couldn't.
Would you think it is? You know.
I doubt it. I think it's all operations and security systems that are interconnected and with different authoritative actors that oversee components of the airport. And if something goes wrong, there would definitely be a command and control room of some kind. But there would be, multiple, border services if you're going to the United States, will have one thing. Et cetera, et cetera. Security cameras would be operated by somebody else. That's probably subcontracted out as well.
Yeah.
And then, of course, all the airlines have their own stuff that's autonomous to them. So they all are in this thing called an airport that is an assemblage of all these systems and subsystems that loosely interact with each other.
Thank you.
Okay, thank you very much, Tracey.
Thank you.